To set this up, I just grabbed the basic bonfire. This isn't a visual effects tutorial. I wanted to explore the relationship of volumes and cops and back and forth. And so all I did was add in here a collision with the pig, so the fire goes around it, and then up here in bonfire, rather than working, rendering out inside of here in the LOPS network that's been added here, I copied this over to stage and just had to reset the path because this path is looking above it in here for these outputs, so I had to repath that. So let's look at my setup here. And so you can see here that I added a couple of file cache nodes to speed it up as we scrub it. And then before bringing this over to the stage and cops, you can bring volumes into cops. I decided, I think most people will work with VDBs, so I convert the VDBs here, and then and those VDBs have, I decided to grab density and flame, and then maybe use velocity, and then I just, I want it as a vector. We can bring the vector into cops, so I, as color or whatever, and so just vector, sort of scalar merge those into the velocity vector. And then I could have volume smoothed this or blurred it, because the voxels get really boxy when they're next to the pixels that we want to sample the voxels from. And so I need to blur it. And I could blur it in cops, or I could blur it here. I found VDB LOD's nice because it's lower resolution and it just side effects blurs it, which is kind of nice. So let's just compare that here. So here's my fire as it is. And then here is my, and then here is my LOD version. You can see it's a lot blurrier, which is perfect for bringing it into cops. It's not so blurry that we don't get detail. So here's sampling the flame volume converted to VDB that has got VDB LOD on it. And you can see I can scrub pretty quickly here. And make sure you put on preserve grid names. And then here it is without the LOD on. And you can see here that the image is getting pretty chunky. You can also use VDB Smooth for this. That's fine too. So let's check out what we brought in. So I've set up a bunch of outputs here to bring into cops, into the stage, and to bring the fire over. So we'll go over the stage and see what I have set up. So basically what I set up is we brought in the basic pig asset, unassigned all of its materials by just getting shape and then star, because I don't want those materials later, and then just transform the pig up so it's above the fire here. And we can just look at where the fire would be here. That'll update. Yep, there we go. So you see here, if we merge that together, that the pig is just above the fire, which is perfect. So I transformed it above the fire, and then did a quick surface material, and let's have a look at that. So quick surface material, when you click on the side buttons over here, it just adds a cop network automatically for you, which is kind of convenient. And the image, the textures images I want to bring in to use on my material is the basic color of the pig, its spec map, and then generating some subsurface and height maps inside of this cop network. So let's have a look in there and see what that setup is. So again, these are pointing to this location inside of here. So let's see what I have set up. So in here I bring in the basic pig geometry, And to get this in correctly, well, there's a number of ways. You do lop import or whatever. I'm doing the SOP modify here and make sure to check on unpack USD prims to polygons. And then also inside of here, I have a mask that I painted.
Side note, this was to test out with attribute paint. I also did it as a texture mask. The nice thing being here is the second output's volumes, which you can then easily bring into as a mask instead of rasterizing attributes.
So that we're only burning and putting blisters at a particular location. And so I'm taking out pig and bringing that into our COP network. And so when I bring this geometry in, you can see it's got the UVs because I brought it through the SOP modify unpacked. And then the way I got the pig texture was, if we go up a level here and just click on any of these, if you look underneath the pig and you look underneath its material here, you can see here there's the low res texture, and then also there's the spec texture. So I can just right click on this and say copy values, and then when I go into my COP network here and just paste those values here. Just a side note, you just have to get rid of the symbols at the beginning and end for that to work. And so now I have my pig texture in here. And then I can put the pig texture right onto the geometry. So let's just do that and see what I have so far here. So I'll just set up a preview material, and we will put it has to be RGBA converted to RGB, and I'll stick that in the base color, and then grab our pig geometry and put that in here. And so now we can preview our material. So indeed we're back to where we were. We've got the pig texture on the pig inside of COPS. And then I also have that mask that I set up, which is saying don't do any effects outside of a certain area. So let's look at where that mask is that I painted outside up at the SOP modify level. And you can see here I inverted it. So I just painted this area and said only burn or make blisters where this mask is allowing it to happen. And then the other thing I needed to do was I needed to be able to sample the nearby voxels of the flame. So let's look at that here. Let's look at our VDB that we brought in. So this again is looking back at our object level here, out VDB. So we're getting our flame and our density and our other volumes here. We're outputting them here, and then we're importing them into our COP network here. And so they're coming in here, and so you can see if I scrub this, there is my flame and density. So I need to sample that though for each pixel of my texture. And so I need to get the world position of each texture. So I can do it here with a wrangle. So here's a wrangle that, I'm not sure why I left it kind of like that. It's strange. Don't need this stuff. It's distracting for you guys. So let's just get rid of that. So basically I need to convert from UV to texture space, which is UV is 00 to 11, and then texture space is -1 to 11, so that fixes that. And then I need to sample the position for each pixel position in UV space. So, so that gives me this map here. And so you can see here RGB equals XYZ. So let's see what that looks like on our pig. And so you can see here that is indeed giving us the RGB equals XYZ values for where each pixel is in world space.
We all know that RGB equals XYZ, so RX, Y green, and blue Z. And looking at where the pixels are, from the texture on the surface. Look at it in UV space here, our texture image, and we have UV coordinates for that, RX, YG, and we want to use our UV position to then calculate the world position using our wrangle, and then rather than using the UV map coordinates, we take the world coordinates back into a new map, a position map, to then use in our next step. Fortunately, the wrangle doesn't produce a map that looks like this. It actually looks more like this, and the advantage is that you can see the map here uses the texture on the surface, and if we were to not have that spillover past the UV islands, we would have this issue. And the issue being there that if we were to use this map as world position as input for 3D noise, you would get some edging issues around the islands like this, versus using the wrangle position map, it smooths it out nicely.
So that's one way of doing it with a wrangle. You can also do it with OpenCL, and I kind of went nuts here, and I don't know OpenCL very well, but barycentric space, Cartesian space, which is X, Y, and Z in a grid, and then you have barycentric space, which is the location within a triangle. And so just getting the barycentric coordinates, this is a sort of standard formula for doing it, and then finding out where, what the attribute value is within that triangle at that specific location. You know, I just had to set up my bindings here for my UVs, point prims, vertex.
So I'm using barycentric coordinates. The surfaces are made out of triangles, and I need to get an attribute value of a position from my UV map relative to where it is within the triangle. And so I've got the position within the triangle, and then I need to get an attribute value based on where it is relative to each of the 3 points. And so barycentric coordinates allow me to do that. Barycentric coordinates are 0 to 1. So you can see here if this is a color attribute on a triangle, and I've got it fully red, fully green, and fully blue on each point of the triangle, and I move this over to the red point, you can see it's out of 1, and then red and then blue and green are 0. And I move it completely away from red, you can see that red is 0 and it's 50 blue, 50 green, and in the middle, as I said, it's 0.33, 0.33, 0.33, 0, 0 to 1. So this allows me to interpolate the attribute color value at this position within a triangle. Now, if I wanted to get the position in 3D space, so this is world position of each of these points. So obviously it's more green up here because it's higher in Y, and it's more red over here because it's farther over in X, and the center of this triangle is kind of around 0, 0, 0. So now if I went to go and look at this in 3D space, same thing, I'm interpolating, and you can see here it's getting less green because it's dropping in Y as we rotate this primitive out into 3D space. You can see, same thing here, I can calculate the using barycentric coordinates, I can calculate the world position attribute out here on that triangle.
I haven't noticed a big speed difference in OpenCL calculating myself. It's probably because of my bad code. I'm sure that's why, actually, versus a wrangle. And then the other advantage of a wrangle is that you can just do it all in one. So you can take UV sample, and then the next step, which is to sample the nearby VDB. So I've got basically, here's my volume, and then here's my surface, and I want to get the nearest voxel value to each pixel. And so in a wrangle, you can do that here, and I'll output, let's output flame into, sorry, I'll move the preview over here so it's easier for you guys. It's a little too far. Let's move it just to here. And we'll output flame into the base color and have a look at what that looks like here. So basically you can see here that I am sampling the nearby voxel values here of flame. And so, and again, I'm just getting it as a scalar. So here's the flame, and then here is each pixel getting the nearby value of that, that flame voxel. So, and then just to compare it to density, density is going to be a little larger, so I decided I'd use density for sort of burning the pig, and then I'll use flame for driving the blisters in a smaller area. Now, you might be asking at this point, like, why don't you just do this manually? Like, just make a mask and animate it, and it'll look really near to the flame, and also it's probably more directable once you get notes and stuff. I just found that the flame, using the actual flame and the pattern it makes, and the results that happen in the cops is a lot more. It makes more visual sense than what you could do manually by hand with a mask, I find. And mixing them together will give you that directable approach anyway when somebody gives you notes. So anyway, so this is saying get the world position, just like here, in the wrangle, and then down here, I don't need V, actually, that is for if we were going to do velocity, I just need volume sample. That's a mistake, sorry. So basically I'm getting a world sample here of a position, and world position sampling from each pixel. And then here, I'm saying density equals get the volume, the density volume. And so basically the way you set that up down here is you add you add some inputs and outputs, and so I added 2 geometry IOs, and then one called density and one called flame, and set them to mono and set these to geometry. And so you can see those inputs here. Now you'll notice they're not named, so and just a little trick, if you actually put this to something else and call this geo, and then put it back to geo, it'll stay named geo. So that's kind of a neat trick, and as an aside. Anyway, and then so I have my geo coming in, and we'll name this so it makes it clear. Let's put this to mono for now and just call this VB, and then go here and set that back to geometry. Okay, and then scrub it so it gets back together. Okay, so now I have geo in and VDB in, and the code up here is basically saying sample the second input, because second geometry input here, which is what that means, and at the position, the world position, of that volume called density, and then that volume called flame, and write out to both of them. And then the way I did it in OpenCL here is very similar. I left some of this garbage in here because this is for when I was doing velocity, so ignore that. But it should look pretty similar to the wrangle, except that you have to set up your bindings here. So I had to set up the name of it, and then what port. So it's the VDB port, and then the volume I want density. It's a float, same for flame, and it's a float. And bring those in, and then say, okay, we need to get that, get that position, and then use that world position and sample for density and sample for the flame volume. So again, it should look pretty similar to what the wrangle is doing. They've side effects. Jeff and all those guys have included some great helpers here. That I mean, I have no idea how to have done this without them making it easier with world sample to evaluate that. But it makes it OCL almost as simple as writing wrangles, which is great. To elaborate a little more on using wrangles and OCL,
to go from VDBs and volumes to COPs. I set up this COP over time volume of an SDF shape star, and so you can see it's showing a different time along Z as we push it through. But the point here is that it's the surface of the pig texture at its UV is sampling the VDB voxel value, and here's a sort of boxify voxel, I guess, example of that. You can see here with same pig on right and left. I just the voxel boxes would have blocked it. So this is just an example of how it's affecting it. Going inside of COPS, you can see here I've imported our VDB and our geo that it's intersecting with, and just like the wrangle we just looked at, but I wanted to elaborate a little bit more on wrangles because I'm not including velocity in this tutorial. So we'll do it as color, which is a vector, just to make it clear. So the way this wrangle is set up, same as the other one, it's getting world position at the UV for each pixel, and then density is sampling the volume. So we're getting density by sampling the volume called density at that world position. And then what's different in this wrangle is that we're getting a volume called C that has color in it, and so we just added a V at the end for volume sample V, and we're just saying V it's equals that and outputting that. The way to set up these wrangles, they're a little different than SOPs, is you have to define your inputs, and so if I wanted to add a geometry input, I just say geometry like I showed you earlier, and then what the import index is. So this one would be, geo would be index 1, and VDB would be index 2. So, and then you would refer to them that way here. You can see by 2 here to get the VDB. And so the nice thing is I'm able to do all of this, getting the world position and volume sampling in one wrangle. OCL, I could probably stick it all in one, but as I showed you before, the OpenCL to get world position is pretty, well for me anyway, to get it smooth, the code's pretty extensive. And then here, what's different between the wrangle and OpenCL is, again, the code looks pretty similar, but again, this time because color is a vector or float 3 in OpenCL, and then we're setting it here, we're just sampling X, Y, and Z, so we're setting C to that. So to set up the OpenCL, I'll just add a node here. So if I wanted to start, the first thing I want to do is I've got some ports set here. So in this case, what I set up was I wanted to input the VDB and also have the output the C in density. So to do that here, you just add them and then say what the types are, geometry, etc. So obviously it's going to be geometry for that. And then in your bindings, you're going to want to give them some kind of a name, and then it's a VDB, and then what port it is, and I just called the port something. No, I didn't call it anything silly, so it's VDB. So the port would be VDB, and then the volume that I'm looking for is C. I should probably call this C2 instead of being silly. And then what I want to say is, I think I said it's a vector, and let me see here, what did I set it as in our bindings? Yeah, a vector, and that's all I had to do was just say whatever I want to call it that I'm going to be using over here in the code, and the port that it's on, and then the name of the actual volume I'm after, and then the data type.
Now I have a map for flame and for density, and I want to use it. So if I was going to put this, let's just look at our pig here, and so you can see here that I'm using flame is going out the pig, but it's not sticking. It's not getting whiter and whiter and whiter where the flame is, which is what I would want. And the reason being is that over here I made a map where I just sort of took the same texture and made it really red as if it was burned, and then I just put that over top of the flame using the flame as a mask here. But in this case, you can see that it's cumulative, right? The flame is cumulative. It's not just passing by. It's actually the flame is adding up over time. And the way I did that was setting up a basic solver inside of COPS. And so this is using the mask. So say, hey, don't consider the flame outside of this area. And then a basic null, just so we know what to grab, called density. So I copy Control CV'd that into a import sock node, and then pasted that into the COPNet here. And then we put that COPNet into a solver. I found it's really useful to pin the solver open and constantly pound reset simulation, because it just doesn't sometimes. And then go into our solver here, and then copy previous and input, and then have 2 COPs for each one of those. So these COPs are SOP imports referring to these 2 SOP nodes. So you have previous frame and current frame, and then you just geo-layer them so that they're COP layers, and then just add them so that cumulatively over time, it's adding 0.2, 0.2, 0.2, 0.2, and eventually the flame, the amount of flame adds up till it gets to, gets lighter or pure white eventually. And so that way we have a solver, and this becomes now, instead of, let's show this first. So instead of flame just again passing the pig by, the flame instead cumulatively adds up. And that way we can use that as a mask again over here to say, have the pig slowly burn, right? Become this other texture. So then I wanted to set up blisters and have the blisters both appear in the texture, and the blisters drive a height map. So but I decided to use flame instead for that, just because it's a slightly different shape. And so this is the flame here, and did the same thing, set up a solver here. And so it slowly adds up. And one of the things I did is, you'll notice it's not as dense really. And the reason why is, in this solver, I decided to add a time shift so that the blisters would show up later after the pig got burned. So I just said, okay, be like 0.8 as, like make it slower by 0.8, and then just shift it by 10 frames so it's later. So it's offset in time. And then basically I said, okay, this is going to be the base of the blisters here. And you'll notice if I put these blisters, and let's just move this preview material down here. If I put these blisters onto the pig, you'll see here, actually that's working pretty good, and that's because I've already fixed it. So let's remove pause, I'll show you what it looks like. So it's not in rolled position, and so you get seam issues, and the noise isn't in 3D space. So I need to set that. So I calculate pause. I can calculate pause with my wrangle here, as like I can use this output, or I could just make one here. So I could do, let me see, I could do at pause equals pause. And so now I have pause here, and so actually I have to add that as a port down here. So so then I can use pause down here, or I can just use it straight out over here, or use it out of the OCL here. So I just take the world position and stick it into the 3D noise here. And so now I don't have any seams, and the 3D noise is in 3D space, which is great. So I'm not animating it or anything, I'm just leaving it as is. I just adjusted some size for where I wanted the blisters and then inverted it because that's more blister-like. And then here, I just did an over of nothing, and the reason is sometimes I make adjustments here to this base, especially for height. It's sometimes useful to do that. I'm sure some people know a better way to handle that, but anyway, let's look at this on the pig, where we are so far. Oops, wrong port, sorry. I'll make people laugh. Okay. Oh, there's a pig. So now you can see here that the blisters are slowly building up as well. And that's because it's driven by the solve here, so that they accumulate as well, but later than the burn is happening. So for the next step, I needed the blisters to get added to the texture map. So here, I'll just move the preview material back over here. And we'll look at where we were with the texture before. So here's our texture. Sorry guys, it's gonna be too far up. So here we are with our density density volume is giving a burn value to the pig. And what I wanted to do was have the blisters show up. So the blisters are down here, and I needed them, so I just brightened them up a bit, and then let me see here. I brightened them up a bit, and then actually that's for inside the blisters, so let's not use that. There we go. So I just yellowed them a bit, and then multiplied this image so far with this other one, and so now you have the blisters on top of the burn area. And then the other thing I wanted is I wanted the blisters to pop after a while. So I used a threshold, and basically that's saying, okay, like once you reach a certain threshold, then show up. And so you can see here that it is like at the very tip of the blister, it's white, but I want the entire blister area to be white. So something you can use is you can use the ID field of the noise here. So let's look at that. So IDs in here. So here's all the unique IDs, right? So if I bring that into something called statistics by ID, then I'm going to get the whole area defined by that value from the threshold. So now I get a map that is the whole area of the burst blister instead of just the peak, the top of the blister. And then I want to make an adjustment on that, like I remapped it just to sort of get an inverse of the blister shape, so that because I want a concavity of the blister instead of the blister bulging out as a mat, So, and then did I use the contrast for something? I'm not sure. Yeah, I did for the height field. So anyway, so basically then I just put this over top of the existing blisters. So this is the blisters bulging out, then these are the blisters in. And don't worry about these edges not merging in that well. I blurred it. And then you can also make some adjustments here to reshape that. So now what I have is the blister burst showing up. So if we do a slider here, you can see as the blisters get bigger, they reach a threshold and switch via the mask to this other texture. So now if I use that in my image up here, you can see here, put our multiply, you can see here that the blisters are bulging out and then popping and changing to the underlying the underlying value. So the other thing I did was I said, okay, let's make a texture to show in that blister area. So so something you can do here is use mono RGB, and so mono RGB lets you put a ramp in. Sorry, I've got the wrong one selected. There we go. And so what it'll do is it'll map this color to the mono values, which is really handy. So this will now be the texture that we see through when the blisters pop in this area here. So just using the mask of our burst here that we made. So this will be our mask, and we're going to show through that mask, we're going to show this image. So, and I also wanted the image to, as it got to a certain point, start to show, and you won't see it in the render. It's kind of sick. I guess I wanted to show something below the tissue here. I'm not sure if this is the right thing to do yet, but this is just a placeholder for now. And so now we look at the over here. Sorry, it's just taking a second to cook. So now we look at it, you can see here when the blisters pop that it's revealing this, this texture underneath. And that might seem a bit extreme, but it all blends in once it's on the surface here. So let's just have a look at where it is down here. Obviously in Karma it's going to blend a lot more, so let's have a look at that. So there we go. So you can see here that the blisters appear and pop, and then when they pop, you know, they reveal this other texture. But we also want that to drive height. So what I did for the height map here is brought the blurred mask here, and then I made a fractal noise just so that there was a bit of bumpiness on the pig mixed in with its specular map, because I wanted some of these wrinkles and stuff from the spec map, and then just averaged them together, and then remapped it so that it's like barely there, but will contribute to the height map. And I just multiplied this with the blister mask, and then brought that into height. And so if we go and look at the pig here with the height map on it, you can see here that the blisters are contributing to the height map based on their luminosity, and then when they pop, same thing, their luminosity, because it's concave. I have to fix this error down here with my mask, but you get the idea that that's now driving the blisters. Now the other thing I did is I took the mass for burst here, and I took the burst mask, and I made another one called emit here. So we're just gotta let that cook for a second. And I took another one called emit, which is a little bit more difficult to set up. And I'm going to use those back to then add, when the blisters burst, to have it shoot out some particles, and then also emit some smoke. So let me show you how to set that up. So basically the burst here is just using the mask we've been using all along, which is this one here. Yeah, the stats by ID one, which is just, we looked at earlier, which is just, you know, wherever we reach a certain threshold from the blisters, you get a mat, right? Now the other thing I needed was, as these appear, I only want the newest ones. I don't, in order for this to like burst and shoot out particles, I only want it shooting particles on the newest ones, not shooting particles on all of them all the time, just on the new ones. So the way I set that up was, again, using a solver. So I took the output of this as burst, brought it into the solver, and I didn't chime shift it, but what I did was in here was say, was just added up like the other one. I don't know what, oh yeah, these are crazy experiments that didn't work. Yeah, I'll leave them in the file if you want to see what I attempted. I thought maybe a difference map would work, but it didn't work. Anyway, I thought diff, maybe previous and next frame, would work to give me only the newest ones, but it just flickered, so I have to revisit that. But this other way works. So basically taking the add, just like the other one, just slowly adding it up. And the reason is you can see they're grayer here. The old ones are grayer than the new ones, right, as it's collecting, and that gives me some values to differentiate them. So I just remapped them here just to get a threshold here. And so now if you look at the threshold, I'm only going to get certain ones. And so I just do an over with that mask. And so now I only get the newest, right, this frame and the last couple of the burst mask instead of getting the entire mask before, which is here. So this is what it looks like without getting the newest parts of the mask. And then this is a trick just to get the newest part of the mask. So I take the outburst, which is here, and I take the emit, which is here, and then let's save where we are now and go back to our object here. And I just decided to stick the rest of them in here. I probably should have put this in the stage, but it was fine. So basically, just to keep things easy, I just copied the bonfire, just copy pasted it over here just so that it's easy just to follow along, make your own. And it's not a visual effects tutorial, so I just wanted to use out of the box stuff. So what it is, I object merge the pig in, and let's just have a look at that here. So object merge the pig in, and then I got the maps that I made from cops. So so I got my UVs here, and then so I got the map. So there's my height map I brought in, and the reason I did that is I wanted the pig to be, and that's broken. I need to go back. So that's a little extreme. That's crazy. So anyway, so I will fix that. So and before I save the file. So basically that is moving. Actually, can I just do it in here? Displacement and just scale it down a bit. Yeah, there we go. That's nuts. I don't know why I scaled it out so much. It's crazy. All right, and then same with this one. We'll just displace this one down a bit too. Oops. Do I have this one? Yeah, there we go. Get in there. There we go. Okay, I don't know, close enough. So the reason I did that is that I wanted to have the values of the pig surface to the displaced pig surface with the blisters and everything, so the smoke didn't go through the blisters and went around the blisters. So then what I did is I went and got, I just wrote over density again, and I got the outburst map, and over here I got the outburst emit map, right, that we made in cops. And so then I just basically clipped this one, and the reason is that way we only have geometry. It's going to take a second to update here. Sorry guys. And that way I only have geometry that I wanted to emit smoke from. And then over here, same thing with this clip. I only had geometry that I wanted to shoot particles out of. And then, what are some other things that I did in here that are unusual? This was just getting the centroid of each one of these pieces of geometry, and then getting sure that the normals were kind of splayed out from the centroid to get kind of a burst shape, smooth burst shape to drive the particles here. And then inside the particles here, I'll just go back to frame one. Inside the particles, same thing, just added a object, the pig, to be a collision object with the particles, so the particles didn't go through the pig. And then cached that out. So, and then what I did was just took the particles. So let's just look at the particles here. So just took, actually we won't look at the particles. Just took the particles and just made a fluid surface out of them. I didn't do anything to it, I think. I might have changed a few sliders, but very little, because I'm not trying to do a visual effects tutorial. I'm just trying to investigate cops with, so you can see here there's some really pretty terrible splashes from blisters coming out, but it's good enough as a placeholder for this demo. And then for the smoke collision, I didn't use the other pyro at the object level. I used the pyro solver and just did VDB in from polygons from the pig and set that into the collision input here for our bonfire. And we'll have a look at that here. And so there's our smoke. So our smoke is coming out. Actually, I seem to have something out. There we go. So it's only coming out where I had the outburst map on the surface of the pig here, right? And same thing for the particles. They're only coming out where I had the outburst emit map. Okay, so that's bringing cops. So we've looked at bringing visual effects elements, sim into cops, volumes into cops, and then this is bringing cops maps out to drive smoke and particles. And so let's look at the overall setup in the stage here. So I then import the smoke into the LOPS setup, and I got to adjust the shader. Obviously, I don't really want it looking like that. And then I brought in the blisters, and actually, sorry, that's Vulkan, so that's fine, because if we look at this in Carmax BU, let's see here. There we go. So yeah, the smoke looks fine. And I'm not sure why this material is angry. Let's see here. Explicit proof. They seem to be blister fluid surface. And then this material is looking for blister spit. Ooh, it's not named right. It's angry. Now you're happy. There we go. So it's sort of a putrid yellow color. And again, just a stand-in, not the best looking effect, but good enough for this exercise. So then we merged it all together. I added just a light, I added a light just to be near to the pig on the side here, and then a dome light just to go over overall light, camera. So we'll just have a look at where our camera is looking here. There's our camera view of it, and then Karma, and that's it. So that is bringing it all together, bringing our COP materials in that are driven by our smoke. And I could have driven it by the embers. That's what I was going to use the velocity from, and the volumes was the direction of the embers would then sort of burn the surface and then vector direct inside of cops. But I just don't think you would have seen it. It's moving too quickly, so I'll make a separate demo from that. But I think that's it. I think that's everything that sort of went into setting this up.